We've looked at arithmetic sequences, we're now looking at geometric sequences. So a geometric sequence is obtained by multiplying one term by a number. Okay? So if our this was our first term, we still call this U1, so the term is still called, each of the terms are still used. How do I get from the first term to the second term? What do I do to it?
Multiply by 3.
Multiply by 3. And to get the second to the third, you will notice the same is happening each time. So the common multiplier, or the multiplier for this sequence, is called the common ratio, and it's given the letter R. Nice letter. So remember, the difference was for arithmetic sequences where you're adding, and the common ratio is when you're multiplying. That's the letter R. If you are given a sequence of numbers and you're trying to find the common ratio, how would you do it? Like, it's not a trick question. It should be an easy answer. Tell me how you would find it. If you're not necessarily, if you're looking at this, you may have said, oh, you multiply by 3, but how can you actually work it out?
You take the U2 and divide it by U1.
Nice. Okay, so you would do U2 divided by 1, or you could do any term divided by the previous one. Okay. The reason I say that is because later on sometimes those values or the common ratio is a fraction, and people get mixed up with it. Okay, so just always remember it would be a later term divided by the previous one. Okay. Okay. So we've said that the first term, term 1, is U1. Term 2 would be U1 multiplied by R. Yep. Term 3 would be U1 multiplied by R squared. R cubed. So in a similar way we did for the arithmetic sequence, how can I write this in general term for n? Remember, this is representing n. Try to tell me how I would write this as a general term.
Well,
Katie?
like we could start with UN minus 1.
Say again?
UN minus 1, like a multiple.
Oh, yes, so I would have, so I'd have this bit, yes, that was common to all of them, so I'd have U1. Is that what you,
Oh,
no,
yeah,
that's not what you
no,
said.
no, I don't know what I'm talking about.
Oh, yeah,
U1 R to the power of n minus 1.
yeah, I thought that's what you were telling me, but no.
Sorry, I was...
Okay. You happy with that?
I don't know what that says.
It's very clear. U1 R n minus 1.
Oh, okay.
Totes clear. Alright, so let's look at some examples. Find the nth term, so we're looking for the general rule. So in order to find the nth term, we're using this un equals u1 r to the n minus 1. So we're going to have n's involved, but we can establish what u1 and r is. So u1 is 2, and r would be 6 divided by 2, which is 3. Yeah? So my un is, God, this board is still headed. 2, and I'm actually going to do the multiply by sign. Ooh. 3. Oh Lord, that's just unpleasant. Okay. Right, consider sequence 8, 4, 2, 1, 0, 1. Ooh, show that the sequence is geometric. So do you remember with the arithmetic one? We showed that there was a common difference between each one, and that common difference was the same. What do you think we're going to do for this one? Yep, so how are we going to do that? Careful. Not 8 divided by 8. Yes. Okay, so 4 divided by 8. Oh, let's use a few words. So let's do u2 divided by u1 is 4 divided by 8. Does 4 divided by 8 simplify? 1/2. Yeah. Now u3 divided by u2 would be 2 divided by 4. Which, oh, funnily enough, simplifying to 1/2. U4 divided by U3 would be 1 divided by 2, which is obviously 1/2. And they've got 5 terms. I guess we should do more. U5 divided by U4 would be 0.5 divided by 1. Well, obviously, if you've got 0.5 just divided by 1, in fraction format, that would be 1/2. So we know that 0.5 is a half. Since the common ratio is 1/2, it is a geometric sequence. I got lazy on the geoseq. Alright, so that's part A. So part B, we're going to find the general term. So to find the general term, remember we need to establish what U1 is. What's U1? 8. And R we just established was 1/2. So UN is going to be anyone? 8. Multiply by. You may want to put your half in a bracket. And part C says we need to find the 12th term, but they specify that we need to leave it as a fraction. So part C, they're telling us to find the 12th term, so we've got U12 is equal to 8 multiplied by 1/2 to the power of 12 minus 1. I can't imagine this would be on the non-calc paper. Okay? So we would have 8 multiplied. Now, because we're leaving it as a fraction, I would suggest you probably want to, you know that that's 11, yes? So we've got 1 over 2 to the power 11. Are you happy with that? And just check that you're all happy with this.
Yeah.
Both of these two things are raised to the power, but obviously 1 to the power of anything is always going to be 1, so I've got 2 to the power 11 here. Yep. So what's this? Your calculator will probably give it to you as a decimal. You need to change it back to a fraction, or work out what 2 to the 11 is.
Many number convert.
One over 256. So what? 1 over 256. We all get that? Trace the answers. Remember, when you have whole numbers multiplied by a fraction, this becomes 8 over 1, just in case. Obviously, Alright, now 3. Ooh, there's those letters. Oh, eeks. So we've got consecutive terms, as we established yesterday, they're one after each other. We need to find K. So this time, what do we know about these things? Remember, last lesson it was that one term subtract the other was the same as another subtract the other. What will you do this time? We're going to divide them. So Cree, do you want to tell me what I'm going to write?
Oh, Cree.
Yeah, I know, you know, there are other people behind you in the classroom, but you know, it's not always. I always say that.
I can't see. I didn't know anybody below the front. Yeah.
Some things don't change mine.
Yeah, you're right.
I've missed you. Alright, so we've got one fraction equals another fraction. How do we solve it? Yep. So we can to undo this division, we would multiply both sides by k minus 1. To undo this one, we multiply both sides by 2k. So in other words, we are bringing these up to the opposite sides. So we've got 2k multiplied by 2k. I'm actually writing it out like that because you may make careless errors when you're multiplying these two things. I'm going to now put these in brackets because again I don't want you to be making silly mistakes. 2k k multiplied by 2k would give me
4k squared.
Nice. We've got two brackets. How do we spell two brackets? Boil it. So we've now got an expression with some k squared, some k's and some numbers. So it's an equation. So what kind of equation is this? Well, we've got k squared. Quadratic. How do we have to solve quadratic equations?
Put it in the column.
You put it out, but we have to do something to it first.
Make it equal to 0.
Make it equal 0. Yeah, so we need to make it equal to 0. I would suggest that if you subtracted 4k squared from both sides, you're going to end up with a negative k squared value. Not so nice. So I'm actually going to suggest that we undo all of those and bring it to the other side. So we've got 4k squared. I'm going to do it in baby steps. You can do it in one step if you wish. And subtract 21k plus 21 plus k squared. Subtract k equals 0. Now I'm going to join like terms. And then we're going to solve it. Let's just use the calcs to solve that right. Okay, so there's our two solutions. We use our calcs to do that. Just double check, in any situation where they've asked for you to find the value of k, just double check that both of them are suitable. And for some practical situations, they may not be. Oh, just
That's
nice.
wrong.
Secretly, they're positive.
Yeah.